Okay, we're continuing our look at linear equations at the end of chapter 6. And the basic linear equation looks like this. So we have three numbers that will be given, a, b, and c, and x is the variable. So ax plus b equals c, and then we want to figure out x. For example, if a is 8, b is -3, and c is 5, then we get this equation, 8x minus 3 equals 5. So how do we solve this? So how do we figure out what x has to be? So we saw last time there are two basic steps. So step A, whatever b is, we're going to subtract that from both sides. And the second step, step B, capital B, divide both sides by little a. So whatever number is multiplying the x, the second step is to divide both sides by that number. So in our example, so solving 8x minus 3 equals 5. Yeah, so b is -3. So we want to subtract -3 from both sides. Yeah, subtracting -3, that's the same as adding 3. I mean, the main idea here is, yeah, we want those 3's to cancel. So we're getting a 0. But 5 plus 3, that's 8. So we get 8x equals 8. And then step B, divide both sides by 8. Since there's an 8 multiplying the x, we want to get 1x. So x is equal to 8 over 8, that's 1. Alright, so those are the two steps. Yeah, we looked at examples last time. And we can check that 1 works. So if you put in 1 here, so 8 times 1 minus 3, yeah, that is equal to 5. Okay, another example. Solve -4x plus 6 equals 1. So yeah, this matches our template with a equals -4, b equals 6, c equals 1. Alright, so first we worry about this 6. So we're going to subtract 6 from both sides. So these cancel, and here 1 minus 6 is -5. All right, and the key thing to always remember in dealing with equations is whatever you do on one side, you have to do the same thing on the other side of the equal to symbol. So after step A, we're left with -4x equals -5. What do we do then? Okay, so the a, the number multiplying the x, is -4, so we want to divide both sides by -4. Okay, so doing that here. So -4x divided by -4, that's 1x. And -5 divided by -4, Remember, negative divided by negative is positive, so we can simplify this to 5 over 4. Yeah, as a mixed number, it would be 1 1/4. But this is fine. Yeah, x equals 5/4. And you can't check that works, so checking the solution. So if you put in 5 over 4 for x, so negative 4 times that 5 over 4. And you can see these 4's cancel. You're just left with negative 5 plus 1. That's plus 6 is equal to 1. Yeah. Okay, how about in the book? Yeah, so the same steps here. So this is our linear equation, and the first step again, subtract b from both sides. Once you've done that, then divide both sides by a. Example 231. Solve the equation negative x plus 5 equals 12. And pointing out here, yeah, that negative x, you can think of that as negative 1 times x. Okay, but first is 5, so we want to subtract 5 from both sides. 5 is the b here. So subtracting 5, we get a 0. Subtract 5 from 12, we get 7. So negative x plus 0 equals 7. Just negative x equals 7. And then remembering, yeah, there's really a 1 here. So now divide both sides by negative 1. So negative 1x divided by negative 1, that's x. And 7 divided by negative 1 is negative 7. Yeah, you could also multiply both sides by negative 1 here to get x equals negative 7. Maybe that's easier. But either way, we're looking for negative 7 as the solution. Yeah, it's a common mistake here to say, okay, negative x equals 7, and then can it just say x equals 7? No, so this really means that the opposite of x is 7, so x itself has to be negative 7. Okay, yeah, so this kind of situation shows up a lot. Of course, yeah, if you're in any doubt, then yeah, if you try 7 in the original equation, yeah, you see it doesn't work. Negative 2 equals 12 is false, but if you put in negative 7 for x, then minus negative 7 plus 5, well, minus negative 7, that's 7. So this, checking carefully, yeah, this does work. X equals negative 7. Yeah, we're just using negative 7, and so the opposite of negative 7 is 7. Okay, how about this example? 232 with fractions, so 3x plus 1/2 equals 1/2. Okay, we're using the same steps. This time b is 1/2 and c is 1/2. So the first step is to subtract 1/2 from both sides. Okay, so subtracting 1/2 from both sides, they both disappear. So we just get 3x equals 0. And yeah, this is also kind of an awkward situation, but it's just remember, yeah, whatever number is multiplying the x, now we have to divide both sides by that number. So we're dividing both sides by 3. 3x divided by 3 is 1x, and 0 divided by 3 is 0. 3 goes into 0 0 times. So yeah, so if 3 times x is 0, then x has to be 0. All right, so those are examples of the basic equation with different numbers. Yeah, a, b, and c can be positive, negative. They could be fractions, decimals. What else can happen? Yeah, so just to make it slightly harder, example 3. So this looks like it has more stuff, but this equation, we have 2x plus 7x plus 1 is equal to negative 3 minus 2. So yeah, there's an extra first step to get this into our standard form. And yeah, right away on the right-hand side, we can see we have negative 3 minus 2. Well, that's so subtracting 2 from negative 3. That's the same as adding negative 2. We get negative 5. All right, so on the right side, it's really negative 5. So that simplifies this piece. And we can do something similar on the left. So 2x plus 7x. So we were combining linear terms last time. So how many x's do we have? So 2x plus 7x is 9x. All right, so this simplifies to just 9x. Okay, so with those extra steps, and now we've got our equation into standard form. So yeah, so 9x plus 1 is equal to negative 5. Okay, so yeah, kind of an important point here is, yeah, these two equations are different. Yeah, they look different, but they're called equivalent because they're really the same. They're telling you the same thing about x. They're going to have the same solutions. Okay, so these are equivalent equations. And yeah, now we continue with our steps. So subtract 1 from both sides next. So 9x is equal to negative 6. Then divide both sides by 9 in step B. So 1x is equal to negative 6 divided by 9. And negative divided by a positive is negative. And this also reduces, cancel 3's. That's negative 2/3. All right, so that's our answer. So the solution is x is negative 2/3. And we could, we could check it. So replace x by negative 2/3. Check that the left side does equal the right side. Okay, another similar example. This time a is a fraction. So 2/3 times x minus 1 is equal to 5. All right, so this is in the standard form. A is 2/3, b is negative 1, c is 5. So subtract b from both sides. Subtract negative 1 from both sides. That's the same as adding 1 on both sides. So plus 1 here, and plus 1 here. So negative 1 plus 1 is 0. 5 plus 1 is 6. So we get to this equivalent equation. 2/3 times x is equal to 6. Okay, step B, we want to divide both sides by this number, by the 2/3. Again, an easier way to do that is to, so dividing by a fraction is the same as multiplying by its reciprocal, if you remember. The reciprocal of 2/3 is 3/2. So the easier way to finish this question is to multiply both sides by 3/2. Okay, so why is that useful? Well, 3/2 times that 2/3, we get 6/6. Yeah, these are reciprocals, so when you multiply them, you get 1. Okay, so just 1x on the left. On the right, it's 3/2 times 6/1. That's multiply straight across. That's 18/2, which is 9. All right, so more work dealing with these fractions, but the answer is x equals 9. And let's check that worked. So if you put in 9 for x, so you have 2/3 times 9/1, that's 18/3. So that's 6. And 6 minus 1 is 5. That checks out. All right, so that's, again, the basic type of linear equation. All right, so let's look at more complicated versions. So the first complication is we could have x's on both sides. And the idea in that case is to subtract one of the linear terms from both sides, so you end up with x's just on one side. Okay, so for example here, now you can see we have x's on the left and on the right. 8x here, 3x here. So one thing we can do is we can subtract 3x from both sides. And why is that good? Well, so 3x minus 3x, what's that? Well, 3 minus 3 is 0, so that's 0x, that's just 0. So 3x minus 3x is 0, cancels. Okay, so we're subtracting 3x from the right to cancel that term, and we're subtracting 3x from the left. 8x minus 3x is 5x. Alright, yes, so we're really doing some algebra here. Alright, so when the dust clears, we're left with 5x minus 3 is equal to 12. Alright, so now we're back to our standard form. Add 3 to both sides and divide by 5, so x is equal to 3. Alright, so just if you have x's on both sides, then yeah, one extra step. Subtract one of those linear terms from both sides. Yeah, we could have subtracted 8x from both sides. That would work too. We'd end up with x's just on the right. And just double checking, so that 3, so if you put in 3 for x, so on the left it's 8 times 3, 24, minus 3 is 21, and on the right 3 times 3, that's 9 plus 12. Also 21, so that checks out. The answer is definitely 3. Yeah, here's one in the book, the same, so x is on both sides. So yeah, it looks like they've subtracted 2x from both sides to cancel one of those x's. Okay, so subtract 2x, that cancels. 3x minus 2x is 1x. So we get to here. Yeah, usually our x's are on the left, but you could have them on the right. Yeah, now we want to just get the x by itself, so subtract 1 from both sides. So x, negative 5 equals x. Of course, that's the same as saying x equals negative 5. Either way, the solution is negative 5. And double checking, so 2 times negative 5 is negative 10. Minus 4 is negative 14. 3 times negative 5 on the right is negative 15, plus 1 is negative 14. So negative 5, that's a good solution. Okay, how about this one? Example 233. Yeah, here we have a different letter, so t's, and we have t's on both sides. Negative 5t plus 6 equals negative 8t. Alright, so we want to get one of these linear terms to cancel. And yeah, what they're doing here is if you add 8t to both sides, well, negative 8t plus 8t is going to cancel. That'll be 0. Okay, so we're adding 8 t to both sides. You could have added 5t to both sides. Maybe that would be easier. Okay, but negative 5t plus 8t is 3t. And so we're left with 3t plus 6 equals 0. Those cancel. Alright, then subtract 6 from both sides and divide by 3. So t is equal to negative 2. And this checks out. 16 equals 16. And we're checking back in the original equation. Alright, so just summarizing our main ideas. So when we're solving these linear equations, so at the start, simplify each side as much as possible. Okay, so we saw that in this example 3, we combine these two numbers and combine the 2x and the 7x. After that, at each step you should be doing the same thing to both sides. So usually subtracting the same number or dividing both sides by the same number. And of course the goal is you want the x's just on one side. And finally, you'd like just one x on one side and a number on the other side. So that'll be your solution. And a good idea, check your solution works, just to make sure you got the question right. Check your solution in the original, in the starting equation. All right, so let's just see another situation that can come up. Okay, so example 6, we have something new on the left. It's we have x plus 2 in parentheses multiplied by 5, and there's also an x on the right. All right, so the new thing we need here is you have to remember the distribution rule. So this 5, it's multiplying the x, we get 5x, and it's also multiplying the 2, so we get 5x plus 5 times 2, 5x plus 10. All right, so just some a little bit of work to do on the left side, and we get 5x plus 10. Yeah, it's not 5x plus 2, it's 5x plus 10. Yeah, we have x's on both sides, so yeah, the best next step is just subtract 1x from both sides. So 5x minus x minus 1x, that's 4x. And these cancel. All right, we're in the standard form. Then subtract 10 from both sides and divide by 4. So x equals 0. Okay, so lots of zeros here. So 10 minus 10 is also 0. Divide both sides by the number multiplying the x. Divide both sides by 4. So 0 divided by 4 is 0. And just checking, so does that work? So when x is 0, this just disappears. We just have 5 times 2. And this also disappears. So 10 equals 10. So that's a good solution. Okay, one more of these. So this time we have a negative number on the outside. Example 7. Negative 3 times x minus 4 in parentheses plus x is equal to 5. All right, so lots of algebra happening on the left. Okay, so we're getting negative 3 times the x plus negative 3 times negative 4. So that's plus 12. And don't forget, yeah, there's still another x on the left equal to 5. All right, so the next step, yeah, we want to combine these two linear terms. So we want to add, yeah, you can just kind of ignore this 12, switch the order here. So yeah, we really have negative 3x plus 1x. And we can combine these. So negative 3 plus 1 is negative 2, so it's really negative 2x. Okay, so 4x plus 7x equals 11x. So just add the coefficients, add the numbers multiplying the x. Negative 3 plus 1 is negative 2, so negative 2x. All right, so after distributing and combining like terms, we get down to the standard form. And now we continue with our steps A and B. So subtracting 12 from both sides next. And we get negative 2x equals negative 7. And then divide both sides by that negative 2. So 1x is equal to negative 7 divided by negative 2. Negative divided by negative is positive. So that's 7 over 2. And that's our solution. Yeah, there were so many steps. Yeah, we could have made a mistake, so definitely a good idea to check. So let's go back to the original equation and try replace the x's with 7 over 2, see if it works. Okay, so working on the inside here, so we have 7 over 2 minus 4. Okay, so that's we're subtracting fractions, we need a common denominator, so that's the same as 7 over 2 minus 8 over 2. Multiply by 2's here. And 7 minus 8 is negative 1, so negative 1/2. Right, so this is good practice. So this whole piece turns into negative 1/2. Next, we multiply by the negative 3. So negative 3 over 1 times negative 1/2. Well, a negative times a negative is positive, and multiplying straight across, that's 3 over 2. Okay, here's the other x, the other 7 over 2. So what's left on the left side, we have 3 over 2 plus 7 over 2, and that's 10 over 2, which is 5. All right, good. So our solution is correct. All right, so that's yeah, this is the hardest kind of linear equation we look at. So just some distributing and then combining like terms. Okay, but the basic linear equation looks like this. All right, so at each stage, yeah, you want to simplify the equation. Just try to get x equal to a number. All right, so that's linear equations.